Hey guys, and welcome to our first flipped video lesson of Unit 2. Hopefully you enjoyed the lessons in Unit 1, and hopefully we'll keep you entertained here in Unit 2. Well, we're moving into a unit based on equations. Last Unit 1 was expressions, this one is equations. In this video we're going to start really simple, start from the ground up, and build a good foundation for the following videos here with our 1 and 2 step single variable linear equations. So we're going to be solving equations. That's probably a word you've heard quite often, but what does it really mean to solve an equation? Well, the idea of solving, we've heard a lot when we watch movies and TV shows and things like that that involve detectives such as, like Sherlock Holmes, or police officers like NCIS or CSI or Law and Order. And when they're trying to solve a mystery or solve a crime, what they're really doing is they are looking for the truth, right? Can you handle the truth? According to A Few Good Men, you can't handle the truth, right? But what it really means is solving an equation means finding something that will make that equation true. Finding a value that we can put into the equation that will make the left-hand side equal the right-hand side. That's what it means for an equation to be true. So if we look at this example here, 3x equals 12. We've got a 3x on the left and a 12 on the right. When we're saying we're solving this, what we're really looking for is a value of x that will make this equation true. Now, this equation is simple enough that we know our multiplication tables, that we should be able to figure out the value of x that will make this true. That is 4. If we substitute 4 for x, we can see 3 times 4 is 12. The left-hand side 12, the right-hand side 12, the left and the right are equal. The equation is true. That means 4 is a solution, because it makes the equation true. This is an important point and an important concept that we are going to carry throughout the year. Anytime we are solving, this is the question we're going to come back to. What does it mean to solve an equation? To find something that makes it true. So, when we're solving our specific single variable linear equations, how are we going to do that? And what we can see is that some equations, like the one we just did, are simple enough that through our intuition or guessing check, we can kind of figure out a solution. But eventually we're going to have equations that are too complicated to solve without coming up with a strategy or a specific system by which we can find our solutions. So what is our strategy going to be for solving our single variable equations? Well, if you notice, when we got to the solution for this equation, the variable was alone. Our strategy, our system is going to be based around the idea that we need to isolate the variable in our equations. And we're going to build all of our tools and ideas around that strategy when we're solving single variable linear equations. So let's start with a one-step equation, meaning we only need to perform one step to get our solution, to get x alone. How are we going to get x alone in this equation? Well, we can see that x is on the left-hand side, and to get alone, we would need to get rid of that plus 5. So how are we going to eliminate the constant that's on the same side as our variable? Well, we're going to eliminate it by using its additive inverse. Remember that term from last unit. The additive inverse is essentially the opposite of that term. So you can see, oops, I went a little fast, let me go back. You can see that to get rid of the positive 5, we're going to subtract 5, and that's going to cancel out the constant on that side. Now, here's the deal. In an equation, we have to stay balanced. It's equal. So whatever we do to one side of the equation, we must do to the other. Which means if I subtract 5 on the left, I also have to subtract 5 on the right. Now x is alone, and we can see 7 is our solution. And we can check our work by obviously doing what's 7 plus 5? It's 12. Then our equation is true. This idea that what we do to one side we have to do to the other is actually a series of properties called our properties of equalities. The concept of this is that, like I just said, whatever we do to one side, we have to do to the other. We have the addition property, the subtraction, the multiplication, and the division, which is just essentially saying if you perform one of these operations on the left or on the right, you've got to do it to the other. Okay, so here are some 4 examples of single variable equations. In a second, we're going to ask you to pause the video and try these on your own, and then come back and check your answers. Ready? Pause. Let's see how you did. So in the first, we can see to get x alone, we had to get rid of minus 12. Well, the additive inverse of negative 12 is positive 12, so we add 12 to both sides, and we can see x is alone equaling 33. And number 2, we have to get rid of a coefficient of 2. There's multiplication that needs to be canceled there. So to undo the multiplication, we have to divide by 2. We have to cancel out that coefficient with division there. And you can see that with 2's would cancel, leaving us with x equal to 25. Now in number 3, we have x being divided by 5. Well, how are we going to cancel out division by 5? Well, we're going to multiply by 5. The 5's would cancel, leaving us with just x equals 35. And the last one here, we have a fraction times x. Well, we can multiply by its multiplicative inverse, its reciprocal. The reciprocal of 1/3 is 3, so I can multiply by 3. It cancels on the left, and 9 times 3 is 27. So hopefully we were able to get these one-step, single variable linear equations solved. But what happens if we have to perform more than one step, right? What happens if there's more than one operation or more than one part of the equation that we have to eliminate? Look at this example. To get x alone, I have to get rid of the coefficient of 2, and I have to get rid of the constant of -7. Now that we have two possibilities, two things we need to get rid of, now order comes into play. Which one do we get rid of first, or does it even matter which one we get rid of first? And the answer is yes, it does matter. And we have a specific order here. First, we're going to eliminate the constant, then we're going to eliminate the coefficient. Eliminate constant, eliminate coefficient. Keep it in that order here. So as we look at this equation, you can see first I'm going to eliminate the constant by taking the additive inverse of -7, which is +7, and adding that to both sides. Then I'm going to cancel out the coefficient of 2, which is being multiplied by x, by dividing by 2 on each side and getting x equals 10. Now that we've had a couple of steps here, and it's not quite as obvious that this is the solution, how do I know for sure that 10 actually is the solution's equation? Well, let's go back to our definition. Does plugging in 10 for x make the equation true? Well, let's verify our solution. Let's do it. So if I plug 10 in for x and simplify, 2 times 10 is 20, 20 minus 7 is 13, 13 on the left, 13 on the right. The equation is true, 10 made it true, and that's why 10 is a solution. So we have 4 equations here. Each of these is a 2-step equation where you're going to have to cancel a constant and you're going to have to cancel a coefficient. So go ahead, pause the video, and try these on your own now. Let's check your answers here. So hopefully you got 15, -29, -5, and -18. If you have questions about these, if you're wondering on 4, what is the coefficient that we needed to cancel there, please make sure you write these down and come to class tomorrow so that we can discuss these. Well, that brings us to the end, and I think that says au revoir, which I believe is French, and I have now doubled my French vocabulary. We'll see you in class, guys.